Hello, my name is Paul Thomas Everett Cusick. I'm an engineer by education. I do research in just about every area that universities teach in, but my main work is a paper that I call astrotheology. Some people call the same thing mechanical philosophy, but I use applied mathematics and the first 2 years of engineering, basically an engineering diploma, to describe the universe. So let's begin. So in this talk, we take all the courses I took in the first 2 years of my engineering degree. We take the main equations and concept learned in those courses. So this paper is intended to form the basis of a 90-minute PhD defense. The talk is divided into 2 parts and 17 sections. The first part is math, applied math, and statistics. The second part is mechanics and other engineering disciplines. So we have structural mechanics, fluid mechanics, soil mechanics, wave mechanics, electricity and magnetism, kind of material science, thermodynamics. So we have all the areas basically covered in the first 2 years of engineering. So we also show how the ancient civilization, the Egyptians, the Babylonians, or the Sumerians, and the Israelites must have known about astrotheology math. So it's not new, it's something that's been around since the time of the Egyptians, we didn't know about it. So there they all are. Part 1, applied math, geometry and trigonometry. Part 2 is number theory. Part 3 is algebra. Part 4 is linear algebra. Part 5 is calculus. Part 6 is differential equations. Part 7 is statistics. And then when we get into part 2, the engineering portion, we get mechanics, statics, and dynamics, which all engineers take, and then soil mechanics and Moore's circle, fluid mechanics and Bernoulli's equation, wave mechanics and harmony, that's the harmony of music, electricity and magnetism, material science and chemistry, thermodynamics and entropy, and then we have skipped over the section on ether. I ran out of room for it, but the universe is filled with ether. I might do a paper on that, talk on that someday too. And then we have modern physics and chaos theory, and the 3 and the 4 line focus, and then ancient mathematical physics based on Solomon's Temple, the dimensions. So part 1 is applied math, geometry and trigonometry. So there are some basic triangles that are used in astrotheology. So we've got the 30, 60, 90 triangle is this first one here. And it's a 1, 2, root 3 triangle. And then we have the golden mean triangle, which is 1, 2, root 5. And then we have the 45-degree triangle, which is a 1, 1, root 2 triangle. And then we have Pythagoras' right triangle, which is a 3, 4, 5 triangle. So from trigonometry, we have the trig identity, sine squared plus cos squared equals 1. That's actually the equation of a circle as well. The equation of a circle is here. Trig identity is here. And the right triangle, a squared plus b squared equals c squared. There's a c squared missing half here. We should know the sine of 60 degrees is root 3 over 2, which is equal to 0.866. And the cosine of 60 degrees is a half. And very important is the fact that the sine of 45 degrees is equal to the cosine of 45 degrees is equal to 1 over root 2, approximately 707. The tangent of 45 degrees is just 1 over 1, which is 1. We should also know that pi radians is 180 degrees, and 2 pi is 360 degrees, which is 6.28 radians. And then we have pi by 3 is 60 degrees, which is 1.047. Pi by 4 is 45 degrees, which is 0.7854. E to the base to raise to the power 1 is 2.71828. Y equals sine theta. Y prime, the derivative of y is cos theta. That's also very important, relates to the sine of 45, the cosine of 45. And y prime prime, or the second derivative of y, is equal to minus sine theta. I put a minus sign in there. And then we should know that the cosecant is 1 over sine theta. Don't confuse that with secant, which is 1 over cos. But cosecant theta equals 1 over sine theta. Energy is equal to 1 over sine theta. When energy and time are equal, and the cross product S is equal to E cross T. So cosecant theta is equal to C, which is the speed of light. And an important trig identity is the cotangent squared. Cotangent is 1 over the tangent. And tangent here is equal to sine over cos. So cos squared theta would be cos over sine. Plus 1 equals cosine squared, which would be c squared. We should know all that off by heart to do astrotheology mathematics. And there is a plot of the 1, 2, root 5 triangle. The golden mean is 1.618. It's one of his roots. Its positive root is 1.618. And the other root of the golden mean parabola is minus 0.618. And we get those from this triangle. 1 plus square root 5, 1 plus or minus the square root of 5 divided by 2 gives you those two values, those two roots. So we have a plot here of the potential energy versus the kinetic energy. Time is simply the kinetic energy. So we have the side of the triangle 1, 2, and we have root 5. And the angle there is 63.43 degrees, which becomes important for Moore's circle later on. So the slope of a line, well, a line is y equals mx plus b. There it is down here. The slope is equal to mc squared, the energy, divided the potential energy divided by the kinetic energy, which is 1/2 mv squared. So when v equals c, the slope is 2. So that brings us back to the triangle we just saw with the y value of 2, the x value of 1. Hypotenuse root 5. So 1 over the time is equal to 0.1576 is pi by 2. Sine of pi by 2 is 1. E, as I said, equals 1 over sine theta, which would be 1 over the sine of 90 degrees, which is equal to 1 over 1, which is equal to 1. So if we take the golden mean parabola here, t squared minus t minus 1 equals energy. The energy is equal to 1. Then we solve that t is equal to minus 1 or 2. So it appears as if t can't be negative. It's a vector. So it has to be 2. And the function that's acting on that is y equals mx plus b. So if we plug the 2 and the 1 into our y equals mx b formula, we equal 1 equals 2x. T is equal to half. A half plugs into the golden mean parabola here and gives the minimum value for the energy. So t equals to half is equal to t min. So the golden mean triangle again is 1 plus or minus root 5 divided by 2. which we can break that up as 1 over 2 plus or minus the square root of 5 over 2, which is equal to the cotangent of theta plus or minus the cosecant of theta. So cotangent is equal to cos over sine, because tangent is sine over cos, plus or minus the energy 1 over sine theta. Energy is equal to cosecant, which is equal to c, speed of light. So cotangent squared theta minus cosecant squared theta is equal to 1 to the power 2, which is equal to 1. So here we have an interesting situation. We have the mass equals 1 over c to the 4th, which is equal to 1 over 81. I'll come out too clearly there. I'm sorry with that. 1 over 81 is 0.012345679. So we're adding a seventh 7 times to have the digit crest over from 7 to 9. And so this is like, it's like coins stacked, and you can calculate the moment from statics. And the important point to realize is the mass is equal to 1 over 81, which is equal to 0.012345679. So from statics, we have the moment is equal to the force times the distance. So the sum of mg is equal to 0. Sum of the moments is equal to 0. So the tipping moment minus the resisting moment, and we have it's equal to when it equals 0. We simplify that as 7, 6, 5, 4, 3, 2, 1 divided by the mass, which is 4. So we can drop the 4 and we end up with 28 over 7 equals m. M equals 4. And F equals mg, that's the Newton's gravitational formula. 4 times the gravitational constant 6.67 is equal to 2.667, which is a superforce, 8/3. So now we jump into number theory. This is our second section of 16 or 17 sections. So we have the volume of a sphere is 4/3 pi r cubed. So 4/3 is space, and pi is t, the ln on the ln function. We'll see a graph later on why t is equal to pi, and r cubed would be the space cubed. So we end up with space to the 4th times t, which is equal to 4/3 to the 4th to t. Volume is equal to 1. And 1 over s to the 4th is equal to 1 over c to the 4th equals 1 over 81. And there you get that number again, 0.1234567, which is the mass. So the speed of light c is equal to the velocity, which is equal to the distance, s or d, same thing, over t, which is equal to s over 1, is equal to s, space. Well, the volume is equal to s, volume divided by s to the 4th equals 1. So the volume is equal to s to the 4th, and volume is equal to c to the 4th, because s is equal to c, is equal to 81. So that's 3 to the power 4. Speed of light to the power 4 is 81. So 1 over the volume is the mass. And then we let space and time be equal, and we end up with t to the 4th equals the distance over the velocity, which turns out that c is equal to 1. 1 over 81 is equal to c. speed of light equals the cosecant of the time equals the energy equals 1 over s to the fourth. T is equal to 1 over s to the fourth. And then the volume ends up being equal to 1, which is equal to T into S. So here's how the universe broke away from the cause and effect. The cause and effect was in effect up until the gravity and the A Coriolis force were equal, and that's when the tangent breaks off the circle. So the force of gravity is equal to Gm. The A Coriolis, the force is equal to m times alpha. So we set those equal. Mg equals ma. The m's cancel. We know that G equals 1, which is equal to E from the Clairaut differential equation. There's the Clairaut equation. And E is equal to G cubed over 3 equals 1 cubed over 3 equals 1/3 equals 1 over C. We know that the dE by dt is equal to the derivative of 2t minus 1. That's the derivative of t squared minus t minus 1. It's equal to 1 over C. So we have t is equal to 2/3, which is equal to g, which is equal to s. And g cubed over 3 is equal to 2/3 to the power 3 over 3. And that's an interesting number. It's equal to 0.9876542, which is the reverse of the 1 over the 81. So g cubed over 3 plus 1 over 81 plus the gravitational plus the mass is 1/9, which is equal to the mass. 1/9 is 0.11111. It's equal to mass. So an equation I called the Sumerian equation, 1 over c to the fourth plus g cubed over 3 equals 1. And do some algebra, and it turns out that that balances. 0 equals 0. So 1 minus e cubed times e cubed minus e squared equals 0. And it turns out that e is equal to plus or minus 1. So to build the universe, we have energy, time, space, mass, velocity, and acceleration. Space, 4/3, time is 1, energy is 1, mass is 1 over 81. V equals A, velocity equals acceleration is equal to 1 over root 2. So part 3 is algebra. So we'll dig into the golden mean parabola here. So the golden mean parabola is x is equal to 1 over x minus 1. If you multiply that out, the x times x minus 1, x times x is x squared minus x. Bring the 1 to the other side is minus 1 equals 0. So x squared minus x minus 1 equals 0 is the golden mean parabola. And sometimes I abbreviate it as a GMP. But it's the critical equation of the universe. So it's a quadratic equation, which was known to the Sumerians. The Sumerians knew about the quadratic equation, which is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And every child studying algebra learns that equation probably about maybe grade 7 or 8 or 9. The Sumerians knew it. So here is the energy time plot. There's the time, there's the energy. And we have the mass is equal to the ln of t. That's this function here. It crosses the t-axis at 1. And the derivative of the ln function is equal to 1. That's the derivative. And the energy is equal to e to the power minus c up here. So the universe mass, positive mass, begins when time is equal to 1, and it ends at t equals to pi, as I mentioned earlier. That's a very important plot, a very important diagram in astrotheology. So we also have another equation that is somewhat important. It's the dampened cosine equation, which y is equal to e to the minus t cos theta. Theta is equal to 60 degrees. So as we know from our trigonometry, cos 60 degrees is a half. And then it turns out that y equals 2.01.4 multiplied by a half is equal to the Reynolds number, 402.8. The ln of 402.8 equals minus t, which is equal to 60 degrees. And there we have the conic sections. We have a plane that's intersecting the cones. And this one up here is the parabola. We also can get a circle or an ellipse if it's on an angle. But the one we're most concerned about is this parabola here because of our golden mean parabola. So the next section we talk about is linear algebra. And we've got parameters. I'm not going to calculate them. I'm just going to tell you what they are, the values for them. The determinant is equal to 4. The eigenvalue is equal to 3. The eigenvector, I show it with t with a line over it, is equal to root 3. And the time is equal to pi, which comes from the eigenfunction of the characteristic equation, which is the golden mean parabola. That's where that comes from. So the product, 4 times 3 times root 3 times pi is 6.529, which happens to be equal to a value called G0, the gravitational constant. I haven't figured out why it's different from 6.67, but I know that the gravitational constant is pi over the ln of the golden mean root 1.618. So it's equal to t, that'd be equal to t over the ln of t equals t over m. So then we have the determinant is proportional to 0.4. We have the period is equal to 251. We have the eigenvalue is equal to 3. We plug the 3 in where the function equals the derivative. This is the golden mean parabola. This is the derivative. When they're equal, energy equals 5. So it would be 3 squared minus 3 minus 1 equals 2 times 3 minus 1. They're equal to 5. The eigenvector, the time. When you plug time into the golden mean parabola, this is the golden mean parabola, t squared minus t minus 1, or pi squared minus pi minus 1, is equal to 57.29 degrees, which is 1 radian. So the golden mean parabola is equal to the energy, so energy is equal to 1, and the time is equal to 1. So in linear algebra, we also have one of the main things is the cross product. E cross t is equal to the magnitude of E times the magnitude of t, 2 vectors, times sine theta. And if we let s equal to t, then we have this s and this t. If they're equal, they cancel. So we have, and we set the dot product, E dot t, equal to the cross product, E cross t. We know that E is equal to 1 over sine theta. E is equal to 1 s over t is equal to 1 because s and t are equal. So E is equal to 1 over sine theta. And sine theta is equal to the force. So E is equal to 1 over force as well. So we do a bit of algebra here and we have theta comes out to be 402. 402 is the Reynolds number, and the universe is filled with ether that was hypothesized back with the Greeks perhaps. And so we have like a fluid in the universe, and so the Reynolds number applies to fluids. It applies to physics of fluids, and it's equal to 402. You can just memorize that. And so the Reynolds number is equal to the inertial forces over the viscous forces, which is equal to ma divided by 1 over root 2 times rho v squared. So it's equal to 4. The mass is 4. Divided by 1/2. 4 by pi is the density. You have to memorize that. Velocity, as we said before, is where sine of 45 equals cos of 45. It's equal to 1 over root 2. So we end up with 4 pi. And we end up with 1.25 is E min, which is interesting, is the minimum of the golden mean problem when t is equal to 1/2. So 1/2 squared minus 1/2 minus 1 is equal to E min. So the density of the ether is equal to E equals 1 over T. Energy equals 1 over time is an important formula. And that comes from the derivative of, if we say mass is equal to energy, and mass is equal to the ln of T, the derivative of mass is equal to the derivative of ln over T, which is 1 over E. 1 over T, I'm sorry. So we have mass over volume equals 1 over T. That's just the density there. Rho is the density. So we have T equals volume over M. 4/3 over 4 is 1 over C. We see that again. T equals 1 over C equals 1 over E. E equals C. But we already knew that E equals C because we knew that E equals cosecant theta, which is equal to 1 over sine theta. It's equal to 1 over 66 sine of 60 degrees, which is 0.866. So the trigonometric identity is important. Sine squared plus cosine squared equals 1 squared. That's the equation of a circle too. Of course, sine and cosine come from the circle. Linear algebra is called such because the underlying formula is a linear equation. Y equals ax, which implies that y equals mx plus b, where b equals 0. That's just the equation of a line. So these two are the same. So the universe is solved by 11 simultaneous equations that are solved by the matrices method. So if you have 11 variables and 11 equations, you can solve them using linear algebra. So there's the cross product of energy and time. And when this hits 60 degrees, your space is the vector that comes out of that. E cross T sine theta is equal to S. It's equal to a vector. Now we have calculus. Let's see what we have to say about calculus. Well, there's the basic curve. It's not a relation. It's a function because it can only be cut once with a vertical line, and it ranges from x1 to x2. And if we take the derivative at x3, we end up f prime of x. We end up with the slope of this line. That's the derivative, the rate of change of the curve. And if we want to know the area under the curve, we take the integral of that function, f of x. So there's the integral. That's just a giant S for sum. So the derivative is equal to the limit of f of x as x approaches 0. From a relation, the unit circle, or the unit circle is a relation, not a function, we get functions such as sine and cosine. So cosecant, there it is again, speed of light equals 1 over sine theta, which you know by now is energy, equals r over y equals the square root of x squared plus y squared. So this is the equation of a circle. So we set the energy equal to that equation, and it results that we end up with energy equals time. So time is equal to the kinetic energy, which is equal to 1/2 mv squared. 1/2, so the mass is 4. 1/2 of 4 times 1 over root 2. 1 over root 2 squared is the velocity squared, is a half. So a half times a half is a quarter times 4 is just simply 1. So energy and time is equal to 1. So the critical point there is that mass is 4. So there we just have that energy plus time is equal to x squared plus y squared. And it works out all right. So aside we have that 1 over sine squared minus 1 over sine equals 1. That's the energy squared minus the energy equals 1. Cosecant squared minus cosecant theta equals 1. We end up energy equals 1 over time is equal to 1 over sine of time equals cosecant of time. Time is equal to 1 over e. So we have the golden mean parabola, and the cosecant theta equals 3. When we plug t as 3 into our golden mean parabola and our derivative of the golden mean parabola, we have energy is equal to 5. So energy equal to 5, t is equal to 3, implies that the function, the golden mean parabola, is equal to its derivative. So t squared minus t minus 1 equals 0, and the roots are, as I said, 1.618 and minus 0.618, which I show in other papers is equal to the imaginary number I. That's what this comes from. And the minimum, when we solve for the minimum of that parabola, t squared minus t minus 1, we have that e is equal to minus 1.25. So e is 1 over t, so t is equal to 8. The superforce is 8 over 3, which is equal to 1 over sine of t. So t is equal to 384 rads. Then we have the cross product. And then we have Poisson's ratio, which is 0.26. Poisson's ratio is the strain in the horizontal direction divided by the strain in the vertical direction, I believe it is. And there's the important point to remember: y is equal to y prime, and the function is equal to its derivative. And that happens when sine of 45 degrees equals cosine of 45 degrees. And 45 degrees is pi by 4, by the way, you should know that. So if we set the function equal to its derivative, we have y equals y prime. This is the exponential function, because the derivative of the exponential function is itself. And it's the only function I know that's true. If we let y equal sine theta, then y prime is equal to cos theta. We know that force is equal to F is equal to sine theta. Momentum is equal to cos theta. So if we set force equal to momentum, it's equal to sine equal to cos, and theta will equal 45 degrees. So this is the same as the dot scalar product. A scalar is a number, mass is a scalar, the cross product, space, is a vector, the cross vector product. So if we set those equal, we end up with theta equals 45 degrees pi by 4. So linear algebra, we have the determinant times the eigenvalue times the eigenvector times the characteristic function, and we end up with t equal to 1 over 555, which equals 1 over 180 degrees, which is equal to 1 over pi, because 180 degrees is equal to pi radians. So the energy is equal to pi. So there's a question here: if you're at a certain point, say at point 2, and you go halfway, you're at 1. And if you're at 1 and you go halfway, you're at a half. And you take halfway, go halfway again, you're at a quarter. You can always take half of a number, so how do you ever get to the point? And the answer to that problem is simply that relatively, when you move a half toward the point moves a half towards you. And when a half minus a half is equal to 0, and that's how you get to the point. That was a conundrum that mathematicians had. So this is it here. There's an odd conundrum in mathematics that I've solved. It goes as follows: if you mark out a point on the floor in the cathedral and start out 50 miles away, you travel halfway. Now you're 25 miles from the cathedral, so then you travel another half and are 12.5 miles away. If you can always take half the distance, how do you ever reach the point on the floor? Should be a question mark. The answer is simple. The motion is relative. As you move halfway to the point moves halfway towards you too. So therefore the distance is 0. There's your sine and cosine functions. So this is your sine function. This is your cosine function. And they're equal at pi by 4. This is 45 degrees. And the value over here is 707, 0.707, or 1 over root 2. So there's your golden mean parabola here. And there's the derivative of the golden mean. It's the linear to a 2t minus 1. It's the derivative of t squared minus t minus 1. And the derivative of 2t minus 1 is t equals 2. So there's your golden mean parabola. So at this point, your E min, your t is equal to a half. And your roots are 1.618 minus 0.618. And note that when t is equal to 0, E is equal to minus 1. So now we'll talk about differential equations. So the Bernoulli equation is used in fluid mechanics, which we will see below is a linear first order differential equation. What we see in this section is the Clairaut second order differential equation. So Bernoulli's equation comes later. The Clairaut equation is the second derivative of the energy minus gravity equals 0, or y prime prime minus y equals 0. So since we know that energy is equal to the golden mean parabola, the derivative is 2t minus 1. The second derivative of energy is equal to 2. So g must be equal to 2. You just bring g to the other side. It's plus g equals the second derivative of energy. G is 2. If you take the double integral of the second derivative, you end up with g cubed over 3. We know g equals 2, so 2 cubed over 3 is equal to 8/3 equal to superforce. Superforce is 8/3, which is equal to 2.666, repeating. So I just mentioned here the three important series that come up in differential equations, and I'm not going to repeat those out. It's just the exponential function, the sine function, and the cos function. So here we have the area is equal to 1/2 the base times the height for the triangle. This is a 1, 2, root 3 triangle. And as the rate of change of mass reaches 2, dm by dt equals 2, and we have this angle theta d theta by dt, we end up with t equals 1/2 t min. So we discussed the Clairaut equation, and then we have the equation of a line y equals mx plus b. So m is the slope, b is 0. So the slope is dy by dx, which is the same thing as y prime. Y prime is equal to y prime plus f of y prime, and if we integrate that to get rid of this y prime, make it y, we end up with this y squared over 2. So y equals 2, which is equal, we just showed energy and time. So if the energy is equal to 2 here, then we end up with t equals 23.02 or minus 13.02. The golden mean triangle has a slope of 2/1, which is equal to the energy and the gravity. So we have an equation y equals mx plus m squared. That's the equation we just got done using. Comes from the equation of a line. Y is equal to y prime x plus y prime squared. 2 is equal to, set y equal to 2 equals, or 2/1. Y squared, or y prime times 1 plus y prime squared. And we end up with y prime squared when it's rearranged, plus y prime minus 2 equals 0. We let y prime equal to energy. That's energy squared plus energy minus 2 equals 0. That's an important equation as well. And if we take one of the roots which we found in the previous slide, 13 squared plus 13 minus 2 is 180. It's approximate, is equal to pi rads. And if we plug the pi rads into our golden mean parabola, we end up with 1 radian, which is your energy. So energy, declared on energy minus G equals 0. E prime prime, second derivative of energy, minus G equals 0. The first derivative is E is equal to 2t minus 1. 2 times pi minus 1 is equal to 250 is equal to the period. The period t is equal to 250, or sometimes 252, it's pretty close to 250. And then we have a solution to a differential equation. We have this curve, and we have a ray coming in. That's reflected off. And we have the golden mean triangles here, 1, 2, and 1 and 2. And this angle in here is equal to this angle here, which is equal to 63.43 degrees. And this is the failure envelope. We'll see that in more circle and soil mechanics. So anyway, if we take these angles, 63.43 plus 63.43 plus 26.56, we end up with 153.42 degrees, which is equal to 2.67 rads, which you recall is 2.666. Repeating is a superforce. So that's for the critical angle when you have the failure of this failure envelope. So then finally, in this end of part 1 in statistics, and we just look at the Gaussian distribution. There's the equation. I'll repeat it. You can see it. You've seen it before. It's the Gaussian distribution of the Bell normal curve. These are the standard deviations, 1, 2, and 3 standard deviations from the mean. Mu is the mean here. So there's the standard deviation, square root of the variance squared. Variance squared equals the sum of x minus mu over n. And in astrotheology, we have these are the 11 simultaneous equations I was talking about before. And if you have a point, and you can go to the left, you can go to the right, and this is 2 to the power n. So we start out here, 1 is equal to 2 to the power n. So n would be 0 here. It runs all the way up to 2 to the power 11, where it's diverging. These are all little branches off a tree, binomial. So it reaches 2 to the 11th, and then it starts to converge to 2 to the 21. That's all I'll say about that. So long as you have a better than 50% chance of winning, you should bet. 50%. This is gambling. So 50% times the prize is equal to T times E equals T squared, since E equals T. T squared is a half, so T is equal to 1 over root 2, which is equal to S equals V equals A, Y equals Y prime. T equals 3 equals 5. That implies that Y equals Y prime. So 2 to the 21, there's our, comes from statistics, divided by the half is equal to 4.18. The ln of 4.18 is equal to 7. 7 crops up all the time in gambling for some reason. But so we have Bernoulli's equation that I promised we'd show you as dy by dx plus p sub x times y equals q sub x. There's an integrating factor, so you multiply each of those terms by the integrating factor, which is equal to 1 plus 1 over 7. And that comes from the mass, which is equal to 0.01234567. So if you have 7 times that value, here it is down here, 7 times that value is equal to 8, which we said was the time. So this is the voltage is equal to the current times the resistance. Of the current is 4/3. Resistance R equals 8. So the time is equal to the resistance. So we showed the universe, DNA, and the brain are telescopic even though they're based on the Gaussian distribution. We do so using the binomial decision tree that is fitted to the mind. We will see that the familiar golden mean parabola, where that function is equal to its derivative. We begin with the Gaussian distribution, probability function for a Bell normal distribution. So there's the Bell normal, the Gaussian distribution is equal to p sub x is equal to y equals 1 over the square root of, should be 2 pi sigma e to the a, where a is equal to minus x minus mu, mu is the average, squared divided by 2 sigma squared. So we follow that all down and the probability comes out to be root 2. And root 2 happens to be where sine and cosine are equal. So the area times 4 is equal to 4 times 1 over that probability times 2.11, it's equal to 5792. So the ln of 5792 is equal to 0.866 equals sine of 60, which is telescopic. Y is equal to y prime equals g, so take the integral of y prime is equal to y is equal to the integral of g, which equals g squared over 2. Probability of x is equal to root 2, set that equal to g squared over 2. G comes out to be equal to 2, which implies that y equals y prime. So SE equals SE prime, that came out of soul energy is equal to the soul energy prime, which is another way of saying y equals y prime. Function equals the derivative, t equals 3, e equals 5. That's here. Then we have y is equal to y prime times, which gives us 1 over t is equal to the ln of t. 1 over t is equal to the ln of 5792, which equals 0.866, which we just saw, which is equal to the energy. Energy is equal to, well, the cross product, S is equal to E, magnitude of E times the magnitude of T times sine of 60. S and T are equal. E equals 1 over sine 60 is 1 over the sine of 60 degrees is 1 over 0.866. Dekker's cube, when the universe meets the mind, is summarized by Euler's identity. Sine squared plus cos squared equals 1. So 1 minus sine squared equals cos squared. 1 minus 0.84 is equal to cos squared. And so the square root of 0.16 is equal to the cosine theta times 0.04. Theta is equal to 66.42, which is equal to 115.9, which is equal to 1 over the sine of 60 degrees, which is equal to E. E is equal to 1 over sine theta, which is the universe. So it's telescopic. And then if we take 115.47 divided by 0.866, we get space, which is 4/3, 1.33. So part 2 is the engineering diploma part, mostly mechanics. We begin with mechanics anyway, statics and dynamics from mechanics, which every engineer takes. So we have the sum of the forces is equal to 0 and the sum of the moments is equal to 0. That's what summarizes statics. And alpha A Coriolis is equal to omega squared r, which is equal to d theta by dt squared times r is 1, radius is 1, equals 1. So alpha is 1, omega d theta by dt is 1 radian per second. Work is equal to force times the distance, which is equal to force times s. S is the distance, is equal to the work. We look at our triangle over here. We have force on the y-axis, and we have space on the x-axis. Space is equal to 4/3, force is equal to 8/3. So the area under this triangle is 8/3 times 4/3 is equal to, multiplied by a half, is equal to 1.777, which is equal to the power, which is equal to the work, which is the square root of pi. So now we get into the dynamics. This is just a cannon, my cannon shooting a cannonball out. It follows a parabola, which we all have seen something similar to that. We throw a ball, or although we may have never seen a cannon actually shoot a cannon, but so we have the distance equation is equal to VIT plus 1/2 AT squared. So distance is equal to s, which is equal to 1/2 AT squared. So 180 degrees divided by pi radians is equal to 3.555 rads, equals 203.68 degrees. 180 divided by pi times 1 over 355 is equal to 1614, which is pretty close to the golden mean parabola. And then we have the Reynolds number as the inertial forces over the viscous forces, which is equal to ma over 1/2 rho v squared. And F is equal to, force is equal to momentum, so force is ma, momentum is mv, set them all equal. mv is equal to 1 over rho v squared. It's 2m divided by the density, 4 by pi. It's about 127.3. That's the density there. We end up with g times m times t, which is g times m is just Newton's gravitational equation, which is force, then times the time, equals 2 pi. Sigma equals, it's Hooke's law here, sigma equals Young's modulus times the strain. So the stress is equal to 1 over s squared, which is equal to Young's modulus, I call it Q's, is pi minus e, which is equal to 0.4233, multiplied by delta all over L is the strain. So we have strain is equal to 1548. And we have that the force of a spring is equal to minus Ks. In structural engineering, we have 3 important diagrams, probably the central diagrams after Hooke's law, and we have a beam, and on that beam we have a load, and the load is equal to 1.339, which is approximately equal to S. And then we have the load, and then we have shear, which is the derivative of the load. We have the moment. So the derivative of the load is WL over 4 equals 0.334, which equals 1 over C. And the moment for a simply supported beam is WL squared over 8, which is 1.667, which is a 6. So in soil mechanics, in part 9, the Morse circle, this is a brief section, we have, there's that angle again, phi, the failure envelope that I mentioned before. This is the failure envelope, and this is all the stresses, the horizontal and the vertical stresses. And this angle theta in here is equal to this angle up here, the angle of the failure envelope. It's a 1, 2, root 5 triangle, which is your golden mean triangle. And you end up with a superforce. So the failure occurs when there's a superforce of 2.666. You end up with the failure envelope. That's the ether. And there it is. Again, there's your curve. There's 1 by 2, 1 by 2. The angle is 63.43. In fluid mechanics and Bernoulli's equation, section 10, we have that Hooke's law, sigma equals Young's modulus times the strain, which equal to force over area, is sigma, equals 1 over E times 1 over A, equals T over A, equals 1 over A. T is 1. And we know that Bernoulli's equation for fluid mechanics is this important equation. So it's the pressure divided by the density times gravitational constant plus velocity squared divided by 2 times the gravitational constant, acceleration, plus the head, h2. That's equal to a constant. And so we end up with the stress 1 over A from here gets plugged into here, plus your potential and kinetic energy. So your potential energy, your kinetic energy, and your strain energy, or the energy built up in the mass, is a constant. 1 over S squared is equal to E squared, because S is equal to T. 1 over T equals E, so 1 over S squared is 1 over T squared equals E squared. And E is equal to the square root of 2, so E squared equals 2. E is equal to root 2, which is the sine of 45 plus the cosine of 45. So we have the distance equation, D equals VIT plus 1/2 AT squared, and we can replace the D by S, same thing, and we have the velocity is S prime, the acceleration is S prime prime, and T and S are equal, so it reduces down and we end up with 1 over S equals E, which is equal to 1 over 7, so there's that 1/7 again. So we have the force is equal. The force is equal to the force in the spring. The force in the spring is minus Ks, and Newton's force is F equals ma. So if we set them equal, ma equals minus Ks, and then we know T is equal to X is equal to the area times the space minus the square root of K over M times M, which is equal to the square root of 1 over 1 equals plus or minus 1. And we plug that into our sigma equals Young's modulus times the strain. F over A equals Young's modulus times the delta L over L. We know that Young's modulus is 0.4233. It just Q's. We know the force is 8/3. We know the area is 1. So we find the strain. Strain is 6.3. So we have Bernoulli's equation again here, and it comes out to the density is 1.273. Force over the area, the surface area of the universe is 19,905. It's a 1 by 8 by 22, or in light years it's a 3 by 24 by 66 ellipsoid, and the surface area of that is 19,905. So 8/3 divided by 19,905 is equal to 1339, which is equal to your piece of X. So there's your 1339. We know the density is 4 by pi. We know the gravitational constant. And then we have 1 over root 2 squared. This is 1 over root 2. Square it is a half divided by 2g. Plus the head is the universal vector, the vector that results from the ellipsoid universe is 12.83 divided by 3 is equal to a constant. So the total energy comes out to be 41.273. So if we take the strain energy plus the kinetic energy plus the potential energy, comes out to the Reynolds number, which is equal to the head. So as soon as the Reynolds number is overcome, the universe begins to flow. Bernoulli again, we end up with T equals 1.618. So first over linear differential equations, dy by dx plus piece of x times 1 over rho g equals h. Then we did some math here on the side. I'm going to skip over. So we have an integrating factor, which is equal to e times the integral of piece of x. We know piece of x is 1.339. So if we plug that, there's Bernoulli's equation again. We plug that in, we get the constant of 1.426, which is approximately equal to a seventh. It's also the economic multiplier, so we get that 1/7 again. The economic multiplier is that if you have $1, someone spends it, they save 1/7 or 15%, 14.26%, whatever it is. And that next person saves the 1/7 again, the 14%. This only goes on 7 times because the dollar runs out. That's an important concept in theology. So now we have wave mechanics and harmony. So simple harmonic motion is given by the differential equation, the second derivative of x with respect to time minus omega naught squared times x is equal to 0. So y prime prime minus omega naught is 1 squared times y equals 0. So y prime is equal to y. Y prime prime is equal to y. That's the Clairaut differential equation. If you bring the y to the other side, set it equal to 0. So the solution to that equation, this equation up here, is x is equal to s, it's equal to t, equals s, equals a constant times sine, and take the derivative of that x, which is a solution to that differential equation, and we end up with cosine. So we have sine and cosine, and when they're equal, you end up with the Clairaut differential equation. So we have simple harmonic motion. So there is Newton's F equals ma. The second derivative of x with respect to time is acceleration times the mass is equal to minus ks, which is the force of a spring. So we know that s is equal to 4/3. We know that k is equal to 0.4233, which is pi minus e, and a 0.5643. So we know that that's equal to 34.36 degrees, or 0.6 rads. So T over equals 1 over E equals 1 over 0.6 is 1.66. So the time is perpendicular to the energy because minus 0.6 is the negative inverse of the time. Of energy, time, minus 0.66, 1.666. The negative inverse means that it's perpendicular. Time is equal to kinetic energy plus 1/2 mv squared. The time is 1 equal to 1/2 mv squared. Mass is equal to the ln of t. Time is equal to 1. So there we just have an equation for the period, which is about 250 or 252 sometimes. And we have now dealing with musical scale, we have an octave beginning with C and ending with C. C, D, E, F, G, A, B, C. 1, 9/8, 81 over 64, 4 over 3, 3 over 2, 27 over 16, 243 over 128, and 2. And so they all are t's. Here they are. Time is 1. 9 over 8 is t squared. Or c squared over t. Remember, t is 8. 81 is m. 64 is 8 squared, so it'll be t squared. 4/3 is equal to the space. Space is equal to time. Then we have 3 over 2, which is the inverse of 3 over 2 is 2 over 3, which is a gravitational constant, which is, we know that g is equal to e, so 1 over g is equal to 1 over e, which is equal to t, so we have t again, t here. And we have 27 over 16 is a little more obscure. You'll see where it comes from, I think, in the next couple slides. 1.6875, and it's equal to t. And 1 over 526 is equal to t. And then you have t times e equals g equals 1 over t. So these are all equal to t, and these are all the notes in music, harmony. So we have e equals 1 over sine theta is equal to 1 over f. F is equal to sine theta is equal to 1 over t. So f is equal to sine theta equals ma. T equals sine theta. Up here, t, 1 over t, 1 over f is 1 over sine. So t is equal to sine theta. And we have the equation I told you to remember, e squared plus e minus 2 equals c. And when t equals 13, the t equals 180, which is equal to pi rads. But if we plug the E min into it, 1.25 squared minus 1.25 squared is a positive, plus a negative 1.25 minus 2 is equal to 1.6875. That's that number that I just told you to remember from harmony. And 243 over 128 is 1.898, which is equal to 1 over 526. So if we plug that into our golden mean parabola, we have the energy 1.249, which is approximately 1.25, which is equal to E min. If we plug that into our golden mean parabola, we have about 81, which is equal to 1 over m. There's a lot of connection between harmony and the universe. So we have the 12th root of 2 is equal to 105.9, which I happen to know is the electromotive force or the voltage. When we have V equals IR, here, that's I is 4/3 and R is 8, if you recall. There it is there, R equals 8. E is equal to 1 over sine theta is equal to 1 over sine theta is cosecant equals 3. So theta is 171 degrees. The sine of 171 degrees is about 707, which is equal to V and A, 1 over root 2. So Bernoulli's equation again, I'm going to skip that slide. So here we have, if we take all those times from the scale, it results in mc squared, which is equal to the frequency of the sum of the frequencies. And we know from Planck's equation that the frequency is equal to E over h bar. C squared equals h bar. So C is equal to 2.574, which is equal to 1 over 0.3884, which is equal to C. We end up with time is equal to pi rads. Mass is equal to the ln of t, which is the ln of that 0.3884. And we end up with 2 to the power 1/12, 1.058. So 1.058 times 4/3 R is equal to 8. So there's a plot of the cosecant, and there is 3, and there's minus 3, and these are asymptotic The cosecant is asymptotic to 3. So the speed of light is 2.99792458, and it's asymptotic to 3. And there's a wave in the ether. So the wave is traveling to the right, and the particles are moving up, and some of the particles are moving down, some of them are moving up, and you have a parent wave that moves this way. But they didn't believe in the ether. But Einstein almost believed in the ether, but he gave up on it. So section 12 is electricity and magnetism, another basic area of the engineering diploma. So we have the circuit. There's your electromotive force. Your resistance is equal to 0.4233, which is Q's. Your capacitor, this is 1 over pi. And your inductor is L is equal to 2. So you subtract the 2 because it's energy coming out, whereas the rest is the energy going in. So V equals IR, the 105 is equal to 4/3 R, R is equal to pi by 4, which is equal to T. So pi by 4 is 45 degrees. Then we have a differential equation that looks pretty scary there, but it's just basically this di by dt is equal to Q. So the charge is equal to the rate of change of the current with respect to time. That's there. So we have a capacitor, we have a resistor, we have our inductor, and it's equal to the rate of change of energy. So E is equal to, energy is equal to F sine theta, so the derivative of the energy is equal to 2. So we can set 2 equal to the sine of 45 degrees, you get 0.2828, which is equal to MA, which is equal to the 4 times A. A comes out to be 1 over root 2. There's your I equals dq by dt. It's equal to 4/3. It's the space, but in the electrical model of things, it's the current I, not to be confused with the imaginary number I. So di by dt is the second derivative of q, and we solve that equation, and we end up with a quadratic equation where the solution is 0.1234567 So quadratic is 1 over 81 is the energy, 1 over c to the 4th. So then we have material science and chemistry, a brief section, section 13. And 2 important facts about astrophysiology is the universe exists where the force and the momentum are equal, that's sine and cosine, and that the moment is 1 minus the sine of 1 radian. 1 radian is approximately 57.29 degrees, or 60 degrees. So anyway, we use those facts in material science. So we have here, we have a face-centered cube with these atoms of material on the cube. And then we have a failure plane which slips through here. There we go. And that's what we call the slip plane. And it is 2 right triangles with a height of h. There's your h. Width b. That's your slip plane, where the ether begins to move. So knowing that the slip plane is area 0.5, we can calculate the critical stress that allows for the failure and thus movement. So sigma is equal to tau over cos theta times cos nu. Let theta equal 45 degrees. So we end up with 1 over root 2 times 1 over root 2 is a half. Tau divided by a half, so it'd be 2 tau is equal to stress. Stress is force over area, which is equal to force is 8/3. Super force we know is the critical force divided by a half, equal to 16 over 3. So tau is equal to 8/3. That's the critical stress. And there's a diagram, your 45 degrees. That's an element. This is an element of your ether. And this is your shear forces. And the force, the critical force is 8/3. So we know from previous papers on astrotheology that the critical force, the superforce, SF, is equal to 8/3 or 2.666. We see from the free body diagram that the critical factor becomes 1/7 of the alternate or the economic multiplier important in astrotheology. So we've seen 1/7 before. So there it is there. This is your 1/7. 8/3, 8/3, 8/3, 45 degrees. This is your tau. So you end up with 1/7. We had previously calculated the ether is 76.6% crystallized. The perimeter of the crystal would be equal to this value, 3.532, which is 14.32%, which is a seventh. So the temperature of the universe is 300 Kelvin, which is about 30 degrees Celsius. So there's your percentage amorphous, 23.3%, crystallized, 76.6%. So the mass plus the time is equal to the total energy. Potential energy plus kinetic energy equals total energy. mc squared plus mgh plus 1/2 mv squared equals 1. C is equal to v. Velocity is equal to the speed of light equals 3. So we end up with 201.7 m equals 1. That's the dampened cosine energy. There's your universal vector, 12.82. So there's your Reynolds number. So the ether, I suspect, is Teflon. It's one of the lowest coefficients of friction that there is. And all the math works out for a coefficient of friction, which I don't have time to go into. But I might do a talk on the ether. I have enough papers, about 10 papers on the ether. Just to take away that the ether is Teflon. So the pressure is equal to 2 over y squared pi r times k squared divided by sigma y. It's equal to 1.25, which is your E min. And your pressure times volume is your frequency. So there's your Reynolds number again. And that is just a material science diagram. I don't have time to go into it. And that's your crystal. So your temperature is 300 degrees. You remember that. Universal vector is 12.82. So we have thermodynamics and entropy. So there again we see this diagram we've seen before, which is your force and your space. So you got space is 1.333 or 4/3, and your force is 2.6, which is 8/3, and your work is your area bounded by that curve. This area, this line has a slope of 0.4233, which is, from Hooke's law, it's pi minus e. It's your Young's modulus for the ether. Velocity equals distance over time. Time equals distance over velocity. Time divided by velocity is distance divided by v squared equals 8/3 squared. 4/3 divided by v squared equals 8/3. V equals 0.707, which is 1 over root 2. And that's right, because we know that the velocity is equal to the sine, equal to the cosine of 45 degrees. So your work is equal to the area under that triangle, which is 1/2 times 2.66 times 1.33. Is your power, 1.77. 1.77 is another key fact, the key number for power, work, energy. There it is there. Power is equal to E times T. So 1.77 equals E times the time is 1. E equals 1.777. Power is equal to E times T, which is equal to F dt. 1.777 equals WT squared. T squared equals 1. T equals 1. Potential energy is equal to the mass plus the gravitational potential energy. And we end up with mgh. The h turns out to be the universal vector. Entropy, S is equal to K times the ln of the work. So we know what the work is. We know what K is, 138. It's a constant. It's a constant that Boltzmann's constant. And entropy. So we know entropy is always greater than 0. Work this out. R is equal to 8, which we've seen before is the time. And if we use voltage is equal to current times resistance, V equals IR, the electrical. It would be the same as mass is equal to S times the entropy. So the entropy is equal to the mass, 4, divided by S, which is 1 over root 2, which is 5656, which is equal to 1 over 17677. It's approximately 1 over the power. And we end up with 2.65 divided by minimum energy. We end up with that number again, 0.9876542, which is reverse of the 0.12345,679. So there we derive Boltzmann's constant, which I don't have time to go into it, but the derivative of the mass divided by the derivative of the space. So the rate of change of mass with respect to the rate of change of space. ds by dt is simply velocity, so it's 1 over root 2, and dm by dt we know from astrophysiology is 2, so we end up 0.2828. Mass is equal to 4, so it's S equals V equals A, 0.707. So Planck's equation is equal to E is equal to H bar V, nu, it's nu, equals 6.626 times 1 over pi is equal to 2109, which is approximately equal to that 2 to the 11th plus 2 to the 11th, 2048. Einstein's equation from modern physics equals mc squared. 4 times 9 is 36. E is equal to h bar nu is equal to mc squared. So 6.626 is h bar times nu equals 4 9s 36. U is equal to 543314, which is an interesting date. And I won't tell you what happened on that date, but you might remember it. And there we have the Hooke's law, energy versus time plot. And in chaos theory, there is an equation x, the t plus 1 of the future case, is equal to k times x times 1 minus x. The growth rate is equal to k is equal to minus 7. 1 minus 1 over k is equal to 1 minus 1 over 7. X equals t equals a half. So x plus 1 is equal to minus 7 over 4, which is equal to 100 degrees. So we have space is equal to E cross T. So 1 over space, 1 over 4/3 is 0.75. That's a critical factor in chaos theory. That's where it comes from. And then 1 over S is equal to 1 over T, because S and T are equals E. E is equal to 1 over sine theta equals 1 over sine theta was sine of 100, 1 over the sine of 100 degrees. 1 over the sine of 100 degrees is equal to, T is equal to 0.984. The fair coin equation, which I calculated from a paper on gambling, actually is T is the golden mean parabola. So if you plug that value of T 0.984 into the equation, we get 101.576. K is greater than 3, then the system's chaotic. K is equal to minus 7, so it's not. We end up with a value of E equal 0.94 and E is minus 0.863. So we have the 3 and the 4 line focus problem. So we have 4 lines here, really 3 lines. There's 2 lines that are equal. Energy and time equal to 1. And that's that line there. And then we have a second line, space, which is this line here. Then we have a third line where energy and time are, we have a third line where mass is equal to 0. So we got the mass, we have the space, and we have energy and time. This one in the back is energy and time when it's a negative, but you only need these 3: space, energy and time, and mass. And the focus is well, we have a triangle that's formed here, a 1 by 4/3 with a hypotenuse of 1/6. So the perimeter is a 6 plus a 4/3 plus 1, which is equal to 4, and the area is 2/3. So 2/3 times 4 is 8/3, which is the superforce. So that's the critical focus point is the superforce for energy, time, space, and mass. What else is there? So now we'll deal with Solomon's Temple, just to show ancient peoples knew about astrotheology, going back to probably the Sumerians, the Babylonians, the Egyptians, and the Hebrews, the Israelites. And Solomon's Temple, which was planned by David. Actually, he wasn't allowed to build it, but it was planned by David to be built around 1000 BC. It was actually built by Solomon, his son, David's son. But all the dimensions in the temple reflect their knowledge of astrotheology. So there's the general layout. In the Bible, it gives the dimensions of the temple. You have a portico here, which is 20 by 20. Has a cubit, and there's dispute over what a cubit is equal to, but I think it's equal to 44 centimeters, which is the length of a man's forearm. So we have a 20 by 20 is a 45-degree triangle, 1 by 1 root 2. And then the diagonal here is root 5 for a 2 by 1 in height, which is 30 cubits by 60 cubits. So we end up with the 1, 2 root 5 triangle. So they knew about the golden mean problem. They had the quadratic equations, so they knew how to solve problems. And they knew the roots, 1.618 and minus 0.618. So they knew an awful lot more mathematical physics than we even knew up until now. And there is a column, and it has all the dimensions, cubits. There's 5 cubits for the head and 18 cubits for the body, and it's got a lot of 23 cubits for the overall height. So it has a lot of the parameters of astrotheology are built right into that building. It's no longer there. So in conclusion, we see that the first 2 years of an engineering degree, sometimes called the engineering diploma, allows us to understand how the physical universe functions. So if you want to know more about this, you can read my books, or you can read my papers. I guess my books are out of print now, but you can find them online for free. And so that is my PhD defense. It's 1 hour and 29 minutes and 36 seconds. And it's all done. There's references. Only used 6 references in putting this talk together. So that's it. Thank you very much, and I hope you've enjoyed the talk. I've enjoyed giving it, and I hope that you've learned something a little bit more about astrotheology, and it whets your appetite for more. Thank you.